Welcome to this particular module, and this is again a experimental component of our lecture or theory class. The today's module will be focusing on how to use 3D printing technique. Now 3D printing, as you know, has evolved several tens of folds from last few years, and now it has been people are exploring the the beauty of 3D printing into several different applications, right from automotive to medical devices. If you recall, in one of the lecture we have talked about a biochip that can be placed within a 3D printed module to understand the tissue properties, right. So, I thought that why do not we also include a small part of the lab where you will be actually shown how you can use a 3D printing module, how you can design this CAD module. Suppose you want to design let us say the casing for this particular microphone, right. So, how this casing can be designed? First you have to design it. So, we will show it to you in the lab how can you design this casing. I will request Said to discuss about this 3D printer and take it over. If you have any questions, again you are free to ask me. Let me again remind you, there would be a certain live sessions as a part of this particular program. Apart from live sessions, there is a forum in which you can ask any technical questions, alright. So, feel free to use the forum in the best possible manner. You take care, and I will hand over the lab to Said. Bye.
Now we want two holes here and here. So, here the inside is hollow. So, how to make two holes? We can make something solid here and here, then we can make hole on that solid surface. So, for making a solid surface, first we have to draw a two-dimensional sketch. So, I will be drawing the sketch on the surface. I will select here and I will click this create sketch button as previously. Then I will make the structure as circle. So, I will make I want to make a hole here. So, I will draw the circle, one circle here. I want a solid structure like this with this much diameter, and inside that I need a hole here like this. Now I want to add the dimension to the circles. The hole dimension should be, the ball dimension was 3 mm. So, the hole dimension we can take it as 2.5, let us say 2.5. Now, the position of the holes are changed. It is okay, we will be fixing everything. Now, 3 more dimensions are needed. We will be adding all those 3 dimensions. This is approximately 3 mm. It will be for a bolt. This is M3 bolt. So, this dimension will be less than 3 mm. And this is, suppose this is the hole we made using 3D printer. If we give a 3 mm diameter in CAD software and made a 3D printing, and after measuring this dimension, it will be less than 3 mm. There will be a string gauge, and that will be anyway less than 3 mm. So, for this screw, there will be threads. If we want to directly screw this bolt, we need this dimension less than this dimension. So we can give 0.5 mm less than the M3 value. So if we put the 2.5 mm hole, and then we can since it is a plastic material, we can directly screw this. While screwing this bolt, we will make a thread in this hole, so it will be a tight fit. So for 3 mm bolt, we will make a 2.5 mm hole, and the solid surface should be around 2 times this value or more. So let's say here we can give 7 mm or 8 mm we can give. This diameter, the outer solid body diameter, cylindrical diameter can be 8 mm. It is recommended to go more than 2 times of this hole, so I will keep 8 mm here. Here the hole dimension will be 2.5 mm and the solid dimension will be 8 mm. And in this enclosure, where we need that hole, that is the question. Now we can go to the old drawing. Now we can switch the screen now. Here, see, here from this center to this edge, that is 8 mm. We have fixed that while designing. This is 10 mm and this is also 10 mm. And from the bottom line to the center line of the circle will be 30 mm. So we can enter this 10 mm dimension and this 30 mm dimension in the CAD software. I will click the dimension tool from the center to this edge, that is 10 mm, and from here to this bottom line, that is 30 mm. So this dimension is from center to here, this line, this outer line, that is 10 mm, and from this center point to this bottom line, that is 30 mm. Now we can finish this sketch. We need one more hole here also. So I will click, first I have to make a solid structure here. I will click finish sketch and then I will go to 3D model. I will click extrude. So for extruding, I want a hole here and a solid body here. So I will click in a space between the circle and the circle. So here, see, it came as a hole. Here in the inside there is a hole and the outside there is a solid body. So the height is 28 mm. This height from here to here also 28 mm. So this will be fine. I will click OK. So here, see, if we rotate, there is a solid body with a hole. The hole dimension is 2.5 mm. We can measure by going inspect tool and measure. The diameter is 2.5 mm and the radius is 1.25 mm. Now as I said, I want to make a plane in the center of this So for making that, I will go to 3D model and I will click this downside arrow, and here we can see there are a lot of options to make planes. First option is offset from a plane. That means from one surface we need another plane at a particular distance. We can choose this option. I will be choosing this one. It's mid plane between two planes. That will be applicable in my case. So I will select this plane and then I will select this plane. So here you can see there is a new plane. Here in this left side we can see my object name is bottom part. I have saved the file. This is the part 3. This is the origin and the planes we have. This is the axes we have, and this is the center point here. Here see, this is the first function I have used, that is to extrude. This was the sketch I have made with 60 mm length and 60 mm height. This is the next function I have used, extrusion, and the sketch was this. Here we can see in blue color that the square length and height was 56 mm, and the dimension between this line, the outer surface and the line here was 2 mm, similarly 2 mm to make a 2 mm wall thickness. And next is the extrusion of a solid body and a hole together. This was the sketch we have made for that. So this is a very useful option in the CAD software, in the Inventor. In all the software there will be a option like, there will be something like this. This is called a tree. So this is our part and this is the tree. So here the plane we have created, and if we want to, suppose if we want to change this dimension of the box, or I want to place this hole somewhere here like 2 mm, I want to change from here to here, then I can directly go to this tree and I can right click here and click edit sketch, and then I can change this value, and similarly the updated object will come. So now I will be mirroring this feature with respect to this plane I have created. So for mirroring, in this 3D model I will select here in pattern there is a mirror. So when I click the mirror feature, the mirror option, first I have to click the feature I want to mirror. So I will click this feature here. I can select the feature here or from the tree. Now I will select from tree. This is the feature I want to mirror, and now I will click here the mirror plane. I will click here, or I can click here to select the mirror plane I want to mirror this feature to mirror about. Now when I click here and press OK, it is the new feature is created, new mirrored feature is created. Now I don't need this plane. I cannot delete it because I made some changes in the 3D object using this plane. I can decrease the visibility of this plane. Here on the plane, click right button on the mouse, and in the visibility, just by clicking here, it will be vanished. Now this is the bottom part I have created. And one more thing is, we want to make a hole here as we discussed. So for making that hole, I want to make a sketch here. Then I want to subtract some material from this object. So I will click on create sketch, and then I will click on circle, and now we have to give dimensions. The circle dimension may be like 10 mm, 1 centimeter. I want to take some wires from that switch, so I need a hole with 10 mm diameter. Now I will enter 10 mm here, and now here if we see, we need 2 more dimensions to constrain this sketch. I will click on the dimension again, and from here to here, now it is 3.633. I will enter 30 mm. This total length was 60 mm. So I want to place this hole in the center, so I will enter 30 mm. From the center of hole to the bottom line, currently it is 19 mm. The height of this box, this bottom part is 30 mm. So I will enter half of that, that is 15 mm. Now the color of the circle has changed to black. Now here we can see it is fully constrained. So I will click finish sketch, and I will use the same extrude feature. In the output, I will change to cut. I will click OK. Now you can see there is a hole. The enclosure bottom part, there is one hole to take the wires out. There are 2 holes to insert the screws. This is one part of our enclosure. So now I will make the top part also. For making that, we have to create another part. So I click the same new standard part file, standard IPT, create. This is the new part. From the tools, in the document settings, I will change the unit to millimeter and kilogram. Click OK. Then I will go to the origin. From the XY plane, I will create a sketch. I will be creating a rectangle, and it will have a provision for 2 bolts, and there will be a rectangular hole for placing the switch. So the dimension I will enter 60 mm and 60 mm as we discussed. Now I will finish the sketch. And I will extrude. As we discussed, the thickness of the top part was 5 mm. I will enter 5 mm here. See, this is the solid part we have created. And I will save this file and give the name top part. I want to make a rectangular hole in the center and 2 holes, in one on the left side and another on the right side. So for making that, I want to make a sketch on the surface. I will click on this create surface. If you just click with the left button of mouse, these options will show. Here you can just click the create sketch and zoom in or zoom out appropriately. Now I will create a rectangle here. As we discussed, the width of the rectangle was 13.5 mm and the height of the rectangle was 21 mm. See, this rectangle is not in the center, so we have to move it to the center. For moving, we can use this dimensions tool. From this side to this side we can calculate the total length was 60 mm and this length is 13.5 mm. So 60 minus 13.5 by 2, 23.25. From here to this line, that should be 23.25. From here to this line, that should be 23.25. Horizontally, now it is in the center. Now we have to align the vertical part also. So the height of the square is 60 mm. Here 60 minus 21 by 2, that is 19.5. From this line to this outer line can be 19.5, or we can fix the dimension between this line and this line. From here to here, that is 19.5. I will click on the finish sketch. Then I will use the same extrude feature, and here I want to select this cut in the output. Now see, we have the top part with a hole for placing the switch. Now I need one hole here and one hole here. So as we did previously, I will create one hole here on the left side, then I will create one hole here in the right side by mirroring this hole with a plane. I will first create a sketch here. The dimension of hole, I will choose 3 mm. The dimension of hole in the bottom bottom part was 2.5 mm. Now here I am choosing 3 mm. The reason is we will be screwing a ball through this hole. So the ball don't have to bind to this part. It should catch the bottom part. So here from this hole to the bolt there should be some gap. That's why I am giving the 3 mm hole. More than 3 mm will be too large for the 3 mm bolt. So I will give just 3 mm. And from the hole center to this line was, as we discussed, that is 10 mm, and from the center to the bottom line, that is 30 mm. I will enter those two values and I will click this finish sketch. I will use extrude feature, and here in the output I will select the cut option and I will click OK. Now you can see I have created a hole in the left side. I will be using a countersunk bolt. So I need a structure here for inserting this screw, inserting the bolt from this surface. So here I will use the chamfer tool and I will select, this is the circle I want to make a chamfer from. So the distance will be, normally the distance will be the half of the size of the bolt. So we are using 3 mm bolt. I will enter 1.5 mm value here. So see, we have created a hole for a countersunk bolt. Now I will mirror this hole and this chamfer about a mirror in the center. So I will create a mirror midplane between both the surface and the surface. So this is the plane I have created. So for mirroring I will use the mirror feature and I will select, I can select this hole from here and the chamfer here, or I can choose from here in this tree. I selected the extrusion and the chamfer. I will select the mirror plane, to select the mirror plane, and I will select. Here we have this old top part with one hole for the switch and two hole for two bolts. I don't need this plane anymore, so I will disable the visibility of the plane. Here right click on the work plane, the plane I have created, and I will select this visibility to disable the visibility. This is the top part I have created. I will save this file, and this was the bottom part I have created. Now I will make an assembly and make this as a total enclosure for the switch. Here in the new, I'll from this new, I will select a standard IAM, a standard part. I'll click on create. This is the new assembly file. I will maximize this document window and now here this is the assembly file. I want to place the bottom part and the top part into this file. For that I will use this place button. This is the bottom part. This is the bottom part I have created. I accidentally make two bottom parts here. I just click escape and I will click this bottom part too in this tree and press delete. I have to place the top part here. I click the top part and I will click open. So let me place it here and I will press escape. Here see, this is the enclosure we will be making, and I will place the top part on the bottom part at the exact place. For that, as we use in this sketch, we have some option for constraining the parts, constraining the dimension between parts. So to place these two objects to the bottom part and top part in place, practically this surface and this surface should be in a plane for the enclosure, and this surface and this surface should be in the same plane, and then this surface and this surface should be in touch with each other. So I will click on the constraint. Here there is a flash constraint, the flash assembly, and here there is a mate assembly. I will use this flash assembly. Here it is showing two parts placed near each other. This is how we need this and this surface and this surface. So I will just click here in the surface, then I will click in the surface. Now I jump to the mate option. I will click here in the flash option. Now this is the way I wanted, but the top part came inside the bottom part. It's okay. I can move it. Now I want to constrain this surface and this surface, the same flush joint. I click OK. Now I want this small surface and this surface to be in touch with each other. I will click on the constraint. Here it is in the mate option. I will click on the surface and then on the surface. I click OK. Here see, now our enclosure is ready. So this is just looking like a square enclosure. So for good aesthetics, we can give a fillet to these edges. That means we can make these edges a little bit curvy. For that, before doing that, I will save this file. CAD enclosure assembly. This is the assembly. When we click the bottom part will show here, and if we click the top part, it will always show. So I want to make a fillet on the edges. I will select this one edge and I will click on this fillet option. In the 3D model, I will click on the fillet option. I want this edge to be curvy. The default value is 2 mm. I will stick on to that. I will select this edge, then I will select this one and this one. I want to make this edge, this edge, this edge and this one to be curvy at the same time. And I will click OK and save. Go to the enclosure assembly. Here we can see it is little bit curvy. So I want to do the same with the top part also. I will select this edge. I will select this edge and then I will click on the fillet. I will click on this edge, this edge and this edge, this edge, this one and this one. I will click on save. Now here we can see the edges are curvy, so it is looking a bit more aesthetic. One advantage of making assembly from parts are, if we miss some dimension or if we entered a wrong dimension value of the top part, and here in this case top part and bottom part, we can see from this assembly. Here we can see these two holes are aligning. Here there is a little bit difference because this circle diameter is 3 mm and here this is only 2.5 mm. Similarly on this circle also, this hole also, and there is a hole for taking the wires out. So we will be using this bottom part file and the top part file for 3D printing. So I will select this bottom part and then I have to save this file for 3D printing. So this Autodesk Inventor software I am using is saving the parts in a .ipt format. I want some other format which can be readable in 3D printer software. So I will go to the file and I will go to the save as option. I will click save as. Here see the default file extension is IPT. I will select here and I want the file in STL format, that is the default file extension for 3D printer softwares. Now this is converted to a vector file in .stl format. I want this top part in the same format, that is STL file. I will click here in the save as, here .stl. Now this one also converted to a vector file.